voltage drop, and what we like to call modern circuit analysis strategies. So we're very thankful for allowing us to present, and hopefully we'll give you something you can use tomorrow for those of you that are always struggling with electrical strategies. As an instructor, I have worked many years as teaching drivability, strategy-based diagnostics, and other related, but most other related items in our transportation arena. But I'm mostly doing light duty diesel nowadays. That's been a big thing. And many times when we talk about electrical, many struggle with electrical. So today I'm going to be working with the 5810 TT, which ATech does manufacture and provide for many out there for them to train on. And I guess we'll put our hand over it right now, and we'll go ahead and show you pretty much what's going on with the ATech. So let's go over here, our board here. We're going to take a look at it for you. And in this case, what we're going to talk about again is, well, I guess the biggest one is that everybody struggles with for the most part is voltage drop testing. And in this case with voltage drop testing, that means that we have to test components to see what's going on. So this is pretty much our trainer. It does have the ability to put faults into it. So we're going to play with one fault later on to show how we do analysis and diagnosis. Yes, I understand that when us as teachers that teach electrical training, we tend to put people to sleep sometimes, or they just shut off for the simple reason at the fact that it might seem too much for them. So we take pride in the fact that we're going to use trainers to get that student, whether being a working technician or a new student in a community college or high school program, that we can use a trainer, get them busy. In other words, start assembling circuit and understand how circuits are. Now, when we talk about diagnosis and we talk about electrical, it all starts with the source. Even when I teach drivability courses with diesel, it's amazing how a lot of guys will miss the bus when it comes, and I shouldn't say bus because we relate that to networks, but we miss the issue about our battery is important. And I'm sure some of you that are experienced probably are saying, all right, that's kind of boring. Yes, but it all starts off with checking our source. Now, the other thing we got to keep in mind is that when we do testing, it is imperative that we have a good meter. We're going to be using the Fluke meter here. That has been a well-proven meter. That doesn't mean that's the only meter out there. We understand that. But in this case, if you are a working technician or you are a teacher, whatever your background may be, you should know that pretty much a meter is very vital. And to be honest with you, when I do electrical training, it's amazing how many out there are using probably less than 50%, if not 40% of the meter's ability, what it can do. So, that's why training is very essential. So we'd like to take pride that we're going to use a meter. So it all starts off with measuring your source voltage. And in this case, you can see up here on the screen that we have 12.6 volts. That is our source voltage. Always check that, because when you do voltage drop testing, you need to know, does it all add up or does it come close to being source voltage? But if we start off with basic circuits that we're going to see, first of all, you got lamps right here. We got lamps. We got resistors as well, too. We have other components here, which unfortunately, we can't cover today, but it's all part of the training that ATech provides by using the 5810 TT. However, we're going to talk about voltage drop testing and the understanding of series and also parallel circuits. So we're going to start off first by, pretty much helping you out here with a basic series circuit. Shall we start off? Now, I already have a cable routed up here to the circuit breaker. Hopefully you all see it pretty good. And in this case, we have a toggle switch right there. So we're going to go after the toggle switch. And what I'm simply going to do is assemble a basic series circuit. There is my one bulb. And at that point, what I'm going to do is I'm just going to go ahead and route it over there. And what we're going to see is we have a chassis ground. Now, please note we do have, and let me move the meter upward just for a second out of the view. You're going to see we have a battery. We have a 5-volt source, but we're not going to be using that, but we're going to be using our 12.6 standard battery voltage source. And down here, we actually can see the symbol here. That is our ground. So we're going to see our chassis ground right here. So there is going to be a difference between what we call our source ground, meaning that is our power ground, versus your chassis ground. And yeah, that's important to understand, because when we look, like when I train doing pinout checks on a diesel, I tell guys to check powers and grounds. And one of the things that they fail to know is there is what we call a power ground, and then there is your chassis ground, or ground. Many people just call it ground, but it's all negative, but there is a big difference. In other words, is there a connection between the negative post of the battery over to the chassis? And the answer is yes, And those of you that know Volkswagen, for example, I worked on old TDIs. I can't tell you how many times we get glow plug codes because simply there's a problem between the battery positive stud going over to the ground chassis, and that's what we see sometimes. Now, We see a series circuit right here. Once again, we have our power, we have our toggle switch, we have our bulb. I know, basic 101s, we turn it on, the bulb turns on, correct? So in this case, we say that in a series circuit, the load must have pretty much the highest voltage drop here. So once again, I'm going to turn my meter on. I'm going to move it back into play here. I can't see the screen there. And in this case, we see the bulb. So the total voltage drop should be across the load. And in this case, we saw that our source was 12.6, but hold on, we got 12.41. So if I go from the negative side of the low side of the circuit over to the ground down here at the bottom here, I'm going to notice that I do have a voltage drop. It might not be high, and it shouldn't be high. It's 0.006. But then if I go from the positive side, in other words, the positive potential over to the battery over here, I'm going to see I have what? 0.15, let me just make sure I can see it, 0.155 volts. So therefore, even though it's a low voltage, it still is a voltage drop. But like the rules of a series circuit state, that we should have the majority of the voltage drop across the load. Now, how can I apply this in real life? Well, in many cases, we talk about, for example, a basic dome light, whether it be an LED or not, it still works with source voltage. So sometimes it's just as simple as going across a headlight, a dome light, whatever it might be. And in this case, we're going to make sure that it actually is getting close to source voltage, which in this case is 12.6. So once again, we see that we have 12.42. We see some drop, which is less than 0.0, actually 0.2, across the positive side of the circuit, or the high side of the circuit, as we like to call. So those of you that are new or actually have limited experience, when we talk about the high side of the circuit, we mostly talk about the positive potential side. While the low side of the circuit, as you can see, we actually talk about the ground or negative side. So since I was trained in a certain way, we call this the positive potential, and we call this the negative potential, because it is potential energy coming from the battery, which in this case, we're using some type of source of power. Regardless though, can you measure voltage drop? Yes, you can. Now, we're going to play a little bit with this a little bit. What we're going to do is going to turn off the circuit, and what I'm simply going to do is I'm going to add, to show a different characteristic of a series circuit, is I'm going to add the second bulb in series. So if we follow the flow, once again, we got power here, and we see the power going past the toggle switch. We go over to the first bulb, then we go over to the second bulb. So we now have two bulbs connected in series, one path. So that's a series circuit. Now, in this case, the question begs, okay, which bulb is going to turn on? Take your best guesses, but in this case, will they both be on dim? Will they both be on bright? None of them will be on, or one will be on, And in many cases, we don't know, because again, what type of bulbs are we talking about here? I mean, you see two lamps right there, but let's go ahead and turn it on. We turn it on, and what do we see? We see that this second bulb is actually turned on. Now, just to make sure you guys don't think that I'm pulling trickery on you, or there's something bugged here. No, it's not. You could see that that bulb is connected in series. It does work, and we see that this one's on. Okay, and if I bypass this bulb, you're going to see that it still turns on. It's not as bright, but in this case, it is illuminating. So the question begs, why doesn't this light turn on? Now, when I see components that don't work properly, again, that's where we use voltage drop testing. So what I'm going to do is, okay, this one is on. So I'm going to say, okay, this one has how much voltage drop? It's got 12 volts. So this guy seems to be taking up the highest voltage drop, while the bulb that is not illuminating is actually what? Got some voltage drop, but less than half a volt. As you can see, they're 0.5, what is it, 0.554? And that's what we see there. So with that said, what we're trying to let you know is, okay, can we have wanted and unwanted resistance? Some people call it bad resistance or good resistance. The classic bad resistance or unwanted resistance would be that battery corrosion at the battery. In other words, those battery terminals don't be clean. And it's funny, because I fight with technicians when they're doing their drivability, is that I tell them, hey, you got to make sure you don't have any unwanted resistance. And sometimes you can visually see it, such as, again, corrosion around the battery post. Very important to understand. So we can say that by doing this voltage drop, this could represent, corrosion on a terminal, corrosion on a battery. So therefore, that's what we're looking at. We do have, again, the load here, but we can see the high voltage drop across this load right here. So if this hasn't caught on yet, let's just understand something. What causes a voltage drop? Since my focus here is going to be mostly voltage drop testing, I guess we should say what causes voltage drop testing, and that would be resistance. There's unwanted resistance or wanted resistance, depending how the circuit is put together. But if you're working on a vehicle, it is under the understanding that it's supposed to work with the source voltage it's supposed to get. Obviously, there could be 5 volts, there could be 10 volts, there could be battery voltage, which is 12.6 ideally. That's what you want to see. So, okay, so we saw this already. We can see we have a problem, but let me show you something though. Another thing that we emphasize, and certain manufacturers might frown on this, but it's necessary sometimes. Let's say, okay, I'm checking voltage drop across this load that is not working. Once again, this bulb is not working, right? Now I want you to pay close attention here. Here's our voltage drop, right? All I'm going to do is show you the difference between open circuit testing and closed circuit testing. So what I'm simply going to do is I'm going to take these 2 leads off. Now, mind you, the 2 leads are off of the bulb, so it's like me taking the connector off. What happened to voltage now? We see 12.6 volts. I reconnected into the circuit, and you're going to see that we have, once again, only 0.3, you know, close to 0.5. It's going up again. But in this case, we see that the voltage measurement that I go across any load is going to change whether the circuit is off or it's on. That's what we're trying to show here. So with that said, how many times if I tell one of my technicians that I work with, I tell them, hey, I need you to measure the voltage going to the, like an ECM or a module. Let's say he's working on a body control module. I need you to make sure, because this thing is not acting normal, because Lord knows I get the fun vehicles that, you know, everybody has struggled with, and I got to make sure, does this body control module or ECM engine control module, whatever it might be, is it getting good source voltage? But many a times, what are you going to do? You're going to actually have the key off, and you're probably going to do it with the connector off. So here you can see I have the connector off. There you go. So we can see, once again, hitting the button here for the illumination, you're going to see source voltage. But when the circuit is on, watch the bulb there, when the circuit is on, you're going to see that the voltage actually is much lower. So that's why, you know, some of us talk about back probing and doing back probing tests. And I know you guys are going to tell me how manufacturers may or may not tell you to do it, but there is a right way to back probe and there's a wrong way, because pretty much every truck, tool truck that comes into our shop back at home, I got to tell you, they're going to be selling some excellent back probing kits. But what I'm trying to say is that there is a difference between, again, open circuit testing and closed circuit testing, and the meter's telling you the story right there. That's why, you know, many technicians out there that I struggle with to try to teach them voltage drop testing, I tell them the test light is a great tool, but again, the meter is your best tool to tell you exactly what's going on here. So therefore, we can see again that the point of highest resistance will have the highest voltage drop. So since this light is on, and it has, with the circuit assembled, the highest voltage drop, as we can see here, of 12 volts, we understand that that has the highest resistance. So it definitely will have more resistance. Now, I'm going to go ahead and disconnect this bulb. We're going to go back to our original bulb here. Let me take this jumper off of here of our trainer. And what I'm going to do is I'm going to go back to our standard single bulb series circuit. Obviously, the bulb's not working, no resistance in the circuit. So therefore, once again, it should have the highest voltage drop. One more time. There you go. Okay, it's got 12.4. We saw that we had about less than half a volt across the positive side. We tested from here to here. Okay, now, with that said, we see the load, we see the voltage drop, but what a lot of people don't understand when I also do training is they're saying, wait a minute, you're checking voltage from positive, positive, negative, negative. Yeah, a good example of that is checking an alternator generator. It should be called a generator, but in this case, they can do an alternator generator where they're testing from the positive post of the battery here all the way to the positive post of maybe of the back terminal on the back of the alternator, right? So in this case, we could simulate that or infer that. And in this case, we can say, hey, do I have a voltage drop there? So one of the testing that we do, again, in charging systems is we tell them, okay, you're going to do a voltage drop against the ground or chassis to, again, the case of the alternator. That could represent negative right there, and you can measure a voltage drop there to see what you got. So let me go ahead and measure that. Because can there be resistance between the case of the generator all the way to the chassis or even up to back to the battery? The answer is yes. So what are we trying to do with voltage drop testing? Once again, we said it was caused by resistance. We're trying to find unwanted resistance, because the next thing that we get into too is also the amperage in the circuit. What is the amperage? So I can move this meter over to amps DC down here. And obviously I have to move my red lead over to the amps. But those of you that are not familiar with your meters, please note, many meters like this one actually have a fuse internal, which is most of them not rated more than 10 amps. So what do I do if I got a higher than 10 amp circuit? Well, you're going to use some type of amp clamp or some kind of inductive clamp that are readily available for your meters too as well. But to illustrate something, we're actually going to go again between the switch, and we're going to be measuring between the switch and the bulb itself, and we're going to be measuring amperage. So in this case, we can see that we're measuring amperage, and we can see roughly, just about, let me illuminate it again, less than 0.258 of an amp, right? So we see that. And again, we do this in our exercises using our courseware. And what we do at this point also is we're going to measure between, again, the negative or ground lead going over to the other side of the bulb. And what do we see there? Again, 0.26. So once again, 0.26. And then if I go even from the source over here, and I go over here to the circuit breaker, should I see similar reading? Yes. So this kind of proves what is always the same in a series circuit is the amperage, because no matter where I measure the amperage, it is always the same as you just saw in all different parts of the circuit. Now, how can I relate this on a vehicle? Well, what about a fuel pump on a vehicle? You got many vehicles have the fuel pump in the tank. You got a wire coming all the way from the tank over to the relay. Well, if I measure it there at the relay, should I see that same amperage as if I were right on top of the tank where the pump is actually connected to, which is submerged in the fuel? Yes, it is. So therefore, we can measure that amperage there at the relay that we see from a fuel system on a typical vehicle. That's what we see there. And yes, on diesels, we also have lift pumps. We call them lift pumps. So therefore, we can do that. But at the same time, going back to what I also mentioned earlier, is that you can also do a voltage drop test. I mean, I saw an instructor once do a whole class on lift pumps. I'm like, well, how much can you talk about on a lift pump, right? It's because we wanted to do also those voltage drop testing, because let's face it, if you have a high voltage drop somewhere in the circuit, not at the pump, will that pump turn slower? And what happens to pressure and volume? It goes down. So basics for some of you it's not, but that could happen. Now, another thing that we're going to talk about is parallel circuits. When we look at a parallel, that means we're giving the circuit more than one path. So in this case, we can see that I'm going to give this bulb another path. So therefore, we're going to connect these two bulbs in parallel. So again, this is my chassis ground, and this is my other ground. So now, as you can see, one bulb does not control the other one. So we can see that right there. Both bulbs are now on. So if I go back and do voltage drop testing one more time, I go across the loads. We already did the ground and the positive side. So what I'm going to do now is I'm going to go ahead and do a voltage drop test across one bulb, and we should have close to source. Once again, turning on the light, 12.3. We saw that 12.6 what we had initially, and we go across the second bulb, and in this case, we should have what? We can have 12.3. So in a parallel circuit, what is always the same is actually voltage, and that's what we're noticing here. It's because each branch has its dedicated path of where it's going to go. So basic understanding of electrical, but it's very important for you to understand that, again, if you're testing a load, whatever component might be on the vehicle, if it's supposed to work with battery voltage, guess what? You're supposed to have that voltage on there, and that's very classic or very common to see. So, and in real life, since I deal with trucks still on a daily basis, I don't just teach full time, I also work on them too, and I train other shops. And it's amazing how many guys will not go ahead and say, hey, you just replaced two pumps and you're still not getting enough volume. Did you go ahead and do a voltage drop test across the pump? Because do relays, as you can see in this illumination, do relays have contacts, and can these contacts become, pretty much high resistance because of constantly open and close? I mean, how many times is a relay, let's say it's a 2005 truck, how many times is that relay turned on and off? So therefore, can it create also resistance? So it wouldn't be surprising to do a voltage drop test across the contacts to make sure we don't have what again? Resistance. And that's what we're looking for. Do we have high resistance across a component? And that's very important for you to understand. It's gotten to the point that when we do, for example, when I work on a Power Stroke 6-liter, it isn't surprising if we need to replace a fuel injection control module, we also replace the FICM relay as well with it, just to make sure everything's good, or a VP44 injection pump on a Cummins 5.9. we also replaced the power relay for that injection pump, because we understand through time those contacts are going to erode. But again, I can verify it if I want to with a voltage drop test. Very important for you to understand there. So, okay, so that takes care of, again, series and parallel circuits. But what about the amperage? You know, we have two dissimilar bulbs right here, and these bulbs, once again, I'm going to go to amperage once again. And in this case, what I'm going to show here, you know, we have two different bulbs, and in this case, I can do once again a amperage test here. So therefore, I'm going to check to see what the amperage or current flow, people like to use current flow, and what is the current flow through here. We could see 0.049. Once again, I am using the meter as a jumper. So therefore, it's part of the circuit. So yes, current is flowing through the meter. And at that point, I see 0.049 on this bulb. And therefore, we see over here on this bulb, we do again a test here. And we're going to see that what? We have about 0.258. So here we see two legs connected in parallel. And since the resistances are different, the amperage or current flow through each branch is different. So again, they can flow this different amount or same amount of current depending how the circuit is designed. So, but if you think about daytime running lamps, for example, manufacturers used to put the high beam side together in series. They would both be on, but there would be a voltage drop across each one. So one would have probably 6 volts, the other one would have 6 volts, yielding roughly 12 volts between them just to get the lights on. But the high beam was not that bright for the simple fact that they were connected in series. So it's interesting how manufacturers used relays to make that happen, to go from a series to a parallel circuit on those applications that are using that. I understand nowadays we're using body modules or body control modules to do that, like on trucks. You also use the power modules too as well to do that job now. But you know, it still happens on earlier vehicles that you may be working on. So please be aware of that there. So, okay, so that takes care of the amperage flowing through the circuit. But what I'm going to do right now is just to show you what we can do with our 5810 TT board is I'm actually going to turn off the circuit. Circuit is off, and I'm going to put a fault here. And in this case, by putting a fault, I'm going to do some testing here, real life, of what can happen. Now, please note, when we're dealing with intermittent problems, especially with electrical, is like saying how big is a rock, right? So in this case, it's not exactly always easy to do. But in this case, we may want to use a meter. And one of the things I love about a fluke meter, it does min-max testing. And min-max testing allows it to record voltage readings usually about, what is it, every 300 milliseconds, it can actually take a reading. So you can see if the circuit ever went open, especially with those intermittent problems. I mean, the most hardest thing to diagnose sometimes on a vehicle depends, but one of the hardest things to diagnose is, you know, does the truck or the vehicle suddenly stall? You know, if it suddenly stalls and then it turns back on, you're trying to find out what actually went out that actually caused it to just just die. So in this case, that's where min-max comes in to check powers and grounds there to see if you actually have an open. So it works very well. Again, highly recommend that fluke meter that actually can do that kind of capability. However, though, we have a fault now, okay? So I'm going to turn on the toggle switch. And in this case, you'll notice that there's no bulbs turned on. But like I said before, we always start off our testing with always confirming your source. So in this case, here is my source voltage. And in this case, my source is still good. I got 12.6 volts. So again, here's my battery. For those of you that didn't see it, that's my battery right there. So we got source voltage. That's pretty good. Okay, that's actually very good. All right, so in this case, the load is not working. I have these two, again, connected in parallel, and I got no power, again, across the load. So in this case, I should have 0. Yeah, I got nothing. I go, this circuit is dead. But the question is, you know, could I do a voltage drop test? I could. So in this case, maybe I have high resistance on the positive side. So I can go from the positive of the battery to the pretty much the hot side. But most of us would start off at the switch and circuit breaker, right? You probably would have checked that. So in this case, I have nothing. I got nothing going on there. So there is no voltage drop, which means there is 0 current flow here. And in this case, if I go once again to the bottom of the switch, in other words, the other side, on side of the switch, again, nothing. And I go over to this side of the bulb, again, I got nothing. So therefore, I just check my positive potential side. Now, why is this important to also mention the high side, like I said earlier? Because have you ever looked at wiring diagrams? Anytime you look at wiring diagrams from different manufacturers, you're going to see what's always on the top of your fuses, especially on the first diagram that comes up for like ECM or PCM, is always showing the power distribution. You know, your positive, that's what we're showing here. So I've checked my positive potential or the high side of the circuit, and then you got, again, the negative potential side or the low side of the circuit. So high, positive, low is often related to negative. So with that said, since we're talking about the negative, let's see what I have voltage drop between, again, the low side of the bulb to the chassis here. Remember, this represents chassis down here. So we can see chassis down here. And what do we have still? We have 0. Okay, so what the heck? I mean, let me go to the other side. Again, I got 0. Now, mind you, I have a fault here. So you're like scratching your head going, okay, we got no power at all. This circuit is totally dead. Well, hold on a second, let's go across the battery once again. Remember, we had source, we had negative and positive, right? There you go, right here at the battery. So in this case, what about the chassis to battery? So let's go from, again, the negative post of the battery right here, representing that, to the chassis. And in this case, what do we see? We got 12.6 volts. Holy Toledo, that's pretty much the whole source. So that means there is what? Between, again, the negative post of the battery and the chassis. We actually have what? We got high resistance. And I mentioned this when I first started, did I not? Where I told you we can have, again, a high resistance fault between the negative post and the chassis. Remember I mentioned the TDI where we get glow plugs? Yeah. So we can do literally a voltage drop test with the circuits on that you are. Like in this case, I can activate the glow plugs or I can turn something on and we could see that there is current flow through it. So therefore that means that I got no power over here because I have massive voltage drop right here, which is just about, it is the source voltage, which you can see there. Make sense? Hopefully that helps you. So let me go ahead and get rid of the fault. Let me again hit my button here, and you can see that the bulb turns on once again, and we got rid of the fault. So that's a good example of a high resistance fault. And believe me, in diesels that I deal with mostly nowadays, this is very important, especially when you got issues with cranking, you got issues with glow plugs and other components, such as even communication with the scan tool is, again, do you have a good connection between the chassis over to the negative post of the battery? And like I mentioned earlier, that's why we even have many manufacturers showing, again, the power ground versus the chassis ground illustrated in the service manual. Now, as I look at you at this camera, I'm going to move my camera so you can look at my ugly mug here. Please understand something. Even when I teach classes and I'm working with wiring diagrams and connector end views such as the ECM or PCM, it is amazing how technicians will not decipher the difference of what is a power ground and what is a chassis ground. Often I've told technicians, you know what? It is best to check all the powers and grounds. For example, we're working on a Ford 6-liter, like an 05 model. Well, I know that on the body connector now there are 3 powers and 3 grounds. And in this case, what I mean by power is there's keep alive power, there's key on power, and then there's direct power, I guess you can say. Then you got your chassis grounds and your power grounds. So if there were to be an issue in, again, the power and the grounds being supplied to the ECM, that'll affect everything else that the PCM or ECM controls. So with that said, you have to confirm that. But what did we show you earlier? Do you want to do it with closed circuit testing or you want to do it with open circuit testing? Remember we talked about how I actually was back probing to see if I had it? I guess what I'm trying to say is it kind of goes back to that term called static versus dynamic testing. In other words, static means at rest, dynamic means it's actually working. Well, I want to test this circuit while it's actually turned on. Even if the engine has a no crank, no start condition, our voltage is very important to understand. In other words, I got no communication, I got a crank, no start. I do see source power at the battery. So you did do big step number 1, which is checking the battery conditions. And then at that point, what do you do now? It's like, well, we got to figure out what is not turning on or if there's a high resistance fault. And in all honesty, it is amazing how many technicians, I mean, some of you are very sharp, and I'm not trying to go after you guys, but I'm going after technicians that are either new, that underestimate the connection. The connection is very important. And have there been many trucks that we have repaired that, we had a loose terminal? So therefore, loose terminals are a big deal. Again, I know it's basic. I know. You're saying, oh, come on, Tony. Yes, we see it a lot in real life. As a matter of fact, my last apprentice that I had working for me, he was amazed how many batteries we're replacing on trucks because of the fact that, again, that was the problem. And you were talking about trucks that have been, out in some other shops for more than a year that nobody could figure out. And it all came down to what? Your source voltage and your battery condition. So very important to understand. All right, let's go back to the board though. Let's talk more about the board here, what we're doing. All right, so we saw again series and parallel circuits. We saw the current flow, and again, you can actually use again your knowledge on understanding that. Hey, okay, Tony said about measuring the voltages that are going to each component. So in this case, that voltage drop testing is very vital to do. But what about when you can't see it? And that's a challenge that us as instructors have sometimes when you can't see it. What do I mean by that? Well, we're going to go here down to this resistor here. In this case, we have a resistor. Yes, I know it's 500 ohms. And in this case, if we go ahead and run directly to it, the resistor is still low. So we're not physically seeing anything here. What I mean by that is I am not actually seeing a bulb turn on, but there's a component that needs to be turned on. So again, toggle switch is off. Once again, we start off with our exercise and we go ahead and measure our source voltage. Again, I cannot stress enough, again, the need to verify your source voltage at the batteries. How's our batteries doing, right? So in this, and by the way, that also means you should be doing either your capacitance testing or maybe you're using some kind of, carbon pile load tester. Hey, that's great. All I'm saying is making sure those batteries and those terminals are clean. Now, at that point, okay, do I have source voltage? Once again, we do. Okay, I talked too much there. Source voltage right there. Okay, now at that point we go across the switch, do a voltage drop across the switch. We should have pretty much minimal. Oh, wait a minute, gotta turn on the switch. There we go. So see how things change just by turning on the switch. So I'm going across the switch. Does the switch have some voltage drop? And the answer is what? Yes, it does. So in this case, again, I know it's minimal, 0.014, 0.013, yes, but there's a voltage drop there. But let's go across the load of the circuit, which in this case is the what? The resistor. So we go across that resistor, and what do I see there? 12.58. So once again, in a series circuit, the component with the highest what? Highest resistance will actually have the highest voltage drop, and that's what we see here. It's the only load in the circuit, right? Here you can see that I got my ground wire going to chassis right there. So once again, we have the voltage drop. But again, without the visual of a light bulb, let's go ahead and put, again, another component in place. So now we're going to use the same resistance here. So in this case, we're going to go ahead and connect these two together, these two 500 ohm resistors together. And once again, I'm going to go ahead and obviously, I didn't turn off the switch, so the switch is still on. So let's go ahead and see what the meter has to say. One more time, turning the light on. We should see two similar resistances sharing that voltage because they are in series. So again, we see 6.2, and we should have pretty close to 6.2 here. Okay, there we go, 6.2 as well. So in this case, we see the same, again, voltage drop because they actually have the same resistances. Earlier we saw that these two lamps right here had two different voltage drops because they were difference in resistance. They were not the same. So in this case here we could see the same thing. But again, if I should see a fault here once again, I would actually see again that I would have, maybe not source voltage here. And I could do that, by the way. I could have put a fault in using the actual 50 ATT, but I will also put in a resistance here in the circuit. So if I put a resistance between the ground and I'm going to use that another 500 ohms. So if I put another resistance in play, again, what happens to now? There's three 500 ohm resistors connected in series here, and in this case, we're going to see that we have how much here? Take 3 into 12, that should be roughly close to 4 volts. That's what we see there. So again, 4.1. What do we have here? We also have 4.1 as well. And we also have 4.1 as well, because again, they're all the same resistances. But they're not getting source voltage, are they? So in this case, that's where we need to connect them in parallel. So therefore, by connecting them in parallel, which I'm going to do right now, I'm actually going to go ahead. By the way, let me turn off that switch one more time just to do the job right. And in this case, we have that. And we're going to connect these two together. So once again, here we could see the circuit being assembled here in parallel. And we're going to see by connecting them in parallel, they're going to actually, once again, have the same voltage drop. But it ain't going to be 4, right? Since they each have their own dedicated path. Again, turn on my meter one more time. We're going to see that we have, once again, wow, we got 12.56. Well, what happened? What happened? Hold on a second. 12.56, really? Yeah, okay. We got 12.56. And we got 12.56 here, and we also have 12.56 here. I got to get my connection right. Here we go. Okay, what is Tony doing wrong here? Tony goofed up here. It's because I don't have this connected. Look at this. Tony goofed up here. One more time. Now I got them connected in parallel. I guess I need to take a class once again. But in this case, I should see source voltage right there. But again, the meter doesn't lie. I saw 0 volts, didn't I? So in this case, I'm noticing that, hey, I don't have enough voltage there. And that's another thing over your certain power probes you might be using, those that don't have a meter, and also test lights. Yes, I know test lights and power probes nowadays have voltmeters on them, but the earlier ones didn't. So therefore, you need to have some type of meter that displays, again, what the voltage is. And I said, hey, I had 0, so therefore, what did I do wrong? Sure enough, I had an open. I didn't have that cable connected. Another reason why the meter should be used. So it isn't surprising when I'm working on vehicles that, you know, the go-to tool for electrical testing is going to be my meter. And those of you that are more advanced probably use a lab scope, which is understandable too. And by the way, for those of you that are anti-lab scope, going back to this camera here, let's get one thing clear about, you know, scopes here. The way I like to approach scopes is that scopes actually are, I like to think of them as a television for seeing what electricity is doing. You know, you can have a lot of things going on. So in this case, it is a great tool. A good example would be is when I'm looking at a waveform of certain components. Have I seen misfires, for example, caused by electrolysis? What do I mean by that? In this case, we have seen voltages, and one of the tests, for those of you who don't know what I'm talking about, is, yes, the manuals will tell you, you're going to take that lead, and you're going to put it in the coolant, and you're going to take your other lead to ground. And what you could literally do is you can actually see if you have electrolysis forming there. So in this case, that'll create pretty much a magnetic field that's generated by that coolant flow into the circuit. And yeah, I have repair trucks and cars that actually have had, you know, a lot of interference because of electrolysis. Yes, 6-7 volts in the coolant. And the question begs, how do I get rid of that? For example, when I've heard of, you know, heater core failure, you know, the soft metals used in heater cores and radiators kind of begs the question, what actually took out and caused the leak? And in many cases, it's actually the electrolysis that was formed. Again, using your voltmeter is very important. Once again, putting that lead in the coolant, the other one in the ground. If you got greater, the books say greater than 1 volt, you should actually go ahead and drain the coolant, but don't stop there. You can actually have a voltage drop between the chassis and the battery, to the point that we no longer get real electrolysis in some vehicles. It's kind of a phenomenon. We literally had to put another ground cable between the block and the chassis or to the battery to give that current. But hold on, I take it a step further. Let me give you an extra tip now that I'm on that subject. When we replace heater cores, we actually either tack weld or clamp on a wire at one of the inlet or outlet of the heater core, and we literally run it to ground to actually dissipate some of the electrolysis that can be generated. So the reason why I brought all that up, by the way, was because on a lab scope, I will be able to see, you know, in many signals from different sensors, such as the crankshaft or camshaft position sensor, I can see that, you know, that AC or that electromagnetic activity. So if you ever visited waveform libraries from different manufacturers, you're going to see that they're showing where you see a voltage, but then you see something around that voltage, which is usually some kind of interference. So therefore, again, yeah, your meter is a great tool. Don't get me wrong. This is our main thing, what you're talking about with voltage drop testing. But however, a scope is even a better tool where you can see what electricity is doing. That's why today's tooling out there has meters built into them with scopes on them. And, you know, I'm really having fun with that because it makes my life a lot easier to diagnose. So for those of you that are working out in the trade, please note that is a valuable tool that you should be using to actually test your charging systems as well, see if there's anything interfering. And if that still doesn't sell it to you, how many times have we seen a vehicle, both on diesel and gasoline, that actually you can see that or you can feel better yet, that the vehicle is idling high and idling low, right? It'll just all of a sudden idle high and then idle low. And in many cases, it could be interference by something called electrolysis or something going on with the charging system, such as AC leakage, which is another test you can also do with your meters to measure AC or ripple test, as we like to call it. But again, that scope is a good tool for that as well. So keep that in mind. All right, going back over here to the board, let's change the camera one more time. So in this case, as we talk about that, you're going to see once again that we did talk about, again, the source voltage. We saw the voltage drops going on here. And at that point, we saw even with the resistors, even though nothing's illuminated, again, they still share the similar characteristics of doing that voltage drop testing. Very important to understand. And we also mentioned about unwanted resistance that we saw clearly between the negative post here and the chassis simulator. So ATech does take a lot of pride in all the crew that works here, showing you how their trainers actually aid you in understanding or hoping understanding of the different situations or issues you can have. So this 5810 board does help a lot, especially me as an instructor. I got to tell you, I ain't gonna lie to you, about actually putting opens and shorts to ground here, which makes life a lot easier to explain what really happens in vehicles today, because that is important to understand. So with that in mind, again, what have we reviewed is that we want you to understand that it is important. Obviously, the meter, good quality meter is very important. And you know what? How many of you have actually looked at your owner's manual of your meters? How many of you get this beautiful meter and you start using it, you start measuring voltage and resistances mostly, right? And in this case, you don't know all the features. Like when we talk about common rail on the 5.9 Cummins injector, they tell you to always measure, again, your resistances, but the resistance specification, hear me out, is greater than 1, but less than, greater than 0, but less than 1, greater than 0, but less than 1. So here you can see that this meter should actually read 0, and you're noticing that, again, we need to go ahead and make sure that it is zeroed out. So therefore, we talk about doing some type of relative check or making sure the meter, because technically 0.1, as you can see the meter triggering, is telling me that I do have some resistance. If I were to put this on an actual coil of an injector, of these common rail injectors, you're going to see that your reading is going to be off. But again, if it's 0.05, truly 0.05, not including the resistance of the meter, guess what? It would have misled you. So it's very important to make sure you also keep proper maintenance of your meter and know all the features of the meter. So again, take time to go ahead and understand what your meter is capable of and know what all these little symbols that are there are telling you. So kind of makes you a better technician so you can use all the features of it. Especially like I mentioned earlier, that min-max feature, so therefore it works very well. So how do we do? It is just about my time up. Any questions there? Well, we're going to do questions, aren't we? What am I saying? I'm teaching like I'm in a class, right? I get excited. Sorry about that. So with that in mind, let's go back and see my ugly mug. How did I do? Hopefully I taught you a little bit. Please note, this is not to substitute what a real life class would be like, but in this case, it is important for you to say, and let me just take a quick second here to say this. If you are a working technician or work in this trade and you're not up to date on this electrical stuff, and now with new EV technology, all that out there, you're going to be struggling, and we would hate you to be a parts changer replacer. So, there is a lot of training out there when it comes to electrical. We highly recommend that you get up to speed on electrical. Hey, you're looking at a guy that back in the day when I used to have black hair that actually took electrical 3 to 4 times by the time I finally got and understood it. And I take pride in the fact that I know it pretty good now. So therefore, hopefully it helps you. But if you don't know electrical, get some training and learn electrical, please. With that, I'm ready for Q&A.
Move too far away from into the technical content from the board that you presented. The instructors that are in the audience have asked if you could repeat the board model number that was there, and then I have one other question after that.
Oh, let's go back to this camera real quick. We'll show them right here. And in this case, it is the 5810. I don't know if you can see it very well, but this is the 5810. This is actually a new model board that's come out. And in this case, it's they're pretty much almost finished up. They're working on the courseware, almost done with it. But again, this is the 5810, and it does have the ability right here to put several faults in different parts of the circuit. You just saw me use one, which was the high resistance fault on the negative side. So it is the 5810 TT. That is the 5810 TT. That's what we're using. Yes, sir. All righty. Does that answer the question? You can go back to me now on the camera.
Yeah, that answers 3 of them. So thank you. Perfect.
Thank you.
And so early on in the presentation, you spoke about unwanted resistance and wanted resistance. Can you please clarify what a wanted resistance in a closed circuit might be?
The light bulb. We just showed you the light bulb, for example. The light bulb is wanted. All bulbs have resistances in them. And in this case, that actually limits the current in the circuit. In other words, what is recommended for it to do its job, to illuminate. I also showed the resistor, the 500 ohm resistor as well. And that would be wanted sometimes. But when we talk about unwanted, like I mentioned earlier, the classic unwanted that I mentioned was the corrosion on a battery terminal. loose terminals. That also will cause unwanted resistance. And I also like to call, I have my own version of also a fault, which I like to call short to resistance. And the reason why I made that up is because I have had two wires actually touch each other, but there's corrosion between them that it won't burn a fuse because there's resistance there. So that's unwanted resistance. Again, so therefore that's going to cause the fuse not to burn, because how many times have we seen faults in live vehicles, especially the flooded vehicles, you know, those that have been through a lot of corrosion. And in this case, that can also cause unwanted resistance that is not supposed to be there. And if that doesn't help, what about that dim headlamp? You can have a high resistance fault either internally in the bulb or externally somewhere in the circuit, but most likely it's a corroded terminal, if that helps. Hold on. The other classic one with charging systems, for example, is actually the gauge of the wire. Sometimes the gauge of the wire thickness is overwhelmed with the high output of the generator that it can actually become resistant. And if that still doesn't help, let me throw one more at you. Is how many times have we seen AC compressors, clutches fail continuously, and nobody ever bothers to measure the voltage drop across that AC compressor? In other words, should it be getting source voltage, 12.6 like we had on our board, or 13, whatever it is? Yeah, because if that clutch is burning up, it's because maybe it's not getting enough voltage because there's too much resistance in the circuit. So that means somewhere in the circuit there's unwanted resistance. And like I mentioned with that, it could be something as frivolous as a relay contacts that are highly corroded. So hopefully that helps you.
Thank you. Tony, can you go back to explain one more time, just clarify positive and negative potential?
Yeah, let's go back to the board here one more time. You see, when you actually have a chemical reaction occurring in the battery, you know, when we say there's two unlike metals in a bed of acid, that makes actually a battery. So yeah, that is our battery. So when we talk about potential energy, that means that potential energy, if the circuit is open, nothing's connected to the battery. Let me take this off. That means here we have potential energy for positive, we have potential energy negative, which means if we break it down even further with electrical, is the gathering of that electrons in one place. That's actually called a charge. But again, when we're talking about positive potential, we're talking about the positive that's on top of the circuit, like I mentioned, the high side of the circuit as well. And then negative potential would apply to the ground or the negative that comes from the battery itself. So hopefully that explains it. In other words, it's the potential energy that's always available. So as that battery sits, there is the potential for the current flow to flow, which is the electrons that are flowing through a circuit. So that's where we get the name potential.
And then back to the wanted resistance, one of the attendees said it's the load that's in the circuit when the circuit is closed, and it's usually a coil of wire, and those examples include the bulbs used today, solenoids such as fuel injectors, ignition coils, the primary side of a relay, etc.
Component that was supposed to work in the circuit, yes, I agree with him. Thank you, yes.
And then the two different bulbs were illuminating at different levels of lumens when you're doing that. Were they two different wattages of bulbs?
Yes, sir.
Yeah.
Yes, sir.
And then for wattage, there's a specific calculation to determine the wattage of a bulb. Is that the power calculation?
Correct. Which is volts times amps.
Okay. Thank you.
So we would, and that's something we teach in our electrical classes where, okay, this is the voltage you measure, this is the amperage in the circuit, can you compute the wattage in there? And the answer is yes, which is volts times amps. I get excited about teaching that electrical stuff. I can go on and on and on here, so. Hopefully that helps though.
So he showed the voltage drop across the load, right? So if you had to shift that over and show a voltage drop, say across a ground circuit, so from the negative side of your bulb to the negative side of the battery, what would be a good reading or an expected reading for a ground that's correct or working properly?
You know, that's been up. Let me be fair here, because I have read articles from different publications out there, but the magic number that I was trained with was actually 0.25, no more greater than 0.25. Some people say 0.15, hell, some people even say 0.5. I state that if there's a high voltage drop there greater than 0.25, you have a problem in that circuit, which in many cases I have proven by cleaning the connections, or actually the wire itself could be the problem, especially if somebody had done some kind of aftermarket installation. So that's very important to keep in mind too, is, aftermarket stuff. Is it the white gauge wire? Let me give you an example. I deal with diesel, right? Freightliner. Freightliner uses white wires. And the thing is, they're all the same gauge. Immediately, what does that tell me? That the current flow through each wire is not the same. So in this case, some circuits are underwired and some circuits are overwired, and that causes, in some cases, voltage drop issues. And you're like, wait a minute, how can a wire be resistant? Because it's too thin to handle the load that it's actually carrying. That's why I welcome you guys to look at manufacturers that produce wiring. In other words, that manufacture cables and wirings. You're going to see that they have specifications for the given amount of current that circuit is carrying and what length it should be and what gauge or actually metric size the wire should be. So.
And then here's a question from Francisco. Going back to the electrolysis you discussed, can a bolted ground around an area of a passage of coolant accelerate the electrolysis occurring?
Can a what, once again?
So a bolt that has a ground wire on it, right? And it's around the area of a passage of coolant. Could that accelerate this electrolysis?
For the simple fact that there goes that unwanted resistance, meaning that you got there's corrosion around the bolt. Yes, that can do it. That's why in many cases we actually take the bolt off and wire brush it and put it back on, and that actually fixes our unwanted resistance there. However, let me be fair here. I have been involved in numerous incidents or issues where I can have two identical trucks and there's nothing wrong with the connections. And some vehicles, for some phenomenal reason, tend to generate more electrolysis than others. So the fix is to literally put an additional cable between somewhere on the block to the chassis. So please keep that in mind that, yeah, I've had vehicles where I've had to put 3 to 4 cables, again, between the block and the chassis or straight to the negative post of the battery just to dissipate that electrolysis.